All right, let's start with this review for the week. Determine if events A and B are independent. Now, how are we going to know if they are independent? The way I'm going to know is I'm going to go probability of A times the probability of B. It has to equal to probability of A and B. If I get that as a true statement, probability of A times probability of B equals probability of A and B, then those are independent. Now, if I get a statement that is not a true statement, then that is not independent, which is what we call dependent. All right, let's take a look at number 17. What I'm asking is 1 over 2 times 1 over 5, is that equal to 1 over 10? Right, I went probability of A times probability of B equals probability of A and B. Is that true? Yes. In this case, it is true. Therefore, because probability of A times probability of B equals probability of A and B, I'm going to call this independent. And let's take a look at number 18. Probability of A is 1 over 5. Probability of B is 1 over 2. Probability of A and B is 9 over 100. Probability of A times probability of B equal to probability of A and B? That's not true. Therefore, these are dependent. Looking at question number 19. I'm asking is if 11 over 20 times 1 over 2 equals 121 over 400. No, that's not true. Therefore, the events are dependent. For probability number 20, is 3 over 10 times 3 over 5, is that equal to 9 over 50? Yeah, it is true. Therefore, these cases are independent. Not too difficult. Now here, for questions 21 through 24, it says, events A and B are independent. Find the missing probability. I'm using the same formula I was using for question 17 to 20. I was using the probability of A times probability of B equals probability of A and B. So let's see. Probability of A is 7 over 10. So I have 7 over times. Probability of B is 1/2. Probability of A and B is, I don't know what it is. All right. Then I just have to multiply on the top. Isn't the when I multiply the two fractions, 7 over 10 times 1 over 2, don't I get 7 over 20? So the left side I have 7 over 20 is equal to x. There you go. Make sure when you type it, just go 7 backslash. All right, let's take a look at question number 22. I have that 4 over 5 times x, because I don't know what probability of b is, equals 2 over 5. Now, to move my fraction, I have to divide by 4/5. So that's basically, I'm going to multiply both sides by 5 over 4. That way that cancels out. Now, 2 over 5 times 5 over 4, I can just multiply straight and then simplify later. Or I can just simplify first. I'm going to simplify first. This 5 with this 5 cancel out. My 2 and my 4 become 1 over 2. So then I have x equals, I just have to multiply the top to multiply my fractions, and I get that x is equal to 1/2. You type that as 1 backslash 2. All right, let's take a look at question number 23. Probability of A is 7 over 20. So let's see, I have 7 over 20. Probability of B is 13 over 20 equals X, because I don't know what probability of A and B is. Now I'm just going to multiply the top. 7 times 13, that's 91. 20 times 20 at the bottom, that's 400. So I'm going to have that 91 over 400 is equal to X. Now for question number 24, probability of A, I don't know what it is. I'm just going to call it X. Probability of B is 1/4, and this is equal to 1 over 16. To have the X by itself, let me multiply both fractions by 4 over 1. So I have that X is equal to, here I'm going to simplify. So I have 1 over 4. X is equal to 1/4. Not too difficult. Let's move on. Let's take a look at question number 25. Find the missing probability. Now here, I have something like probability of B, probability of A not B, probability of A and B. There's a couple formulas I'm going to use. I'm going to say that probability of A times probability of B not A is equal to probability of A and B. I'm going to use that if I have probability of A and probability of B not A. As an example, question number 26. Now, what if I have something like 25? I'm going to use a different color for my other formula. What if I have probability of B? So in that case, I'm going to say probability of B times probability of A not B is equal to probability of A and B. All right, so that's not that bad. So let's take a look. For question number 25, I'm going to use my red formula. Probability of B is 3 over 5. I'm just going to say 3 over 5 times probability of A not B is 1 over 4. And this is equal to X because I don't know what probability of A and B is. Just multiply your fractions. You know how to multiply. Just multiply straight. I'm going to have that 3 over 20 is equal to X. When you type it, just type in 3 backslash 20. All right, just 3 over 20. Let's take a look at question number 26. I'm going to use the blue formula. Probability of A is 7 over 20. Probability of B not A is 11 over 20. Probability of A and B, I don't know what it is. So I'm going to call that X. And then just have to multiply the top, multiply the bottom. There's nothing I can simplify. So I have that 77 over 400 is equal to X. When you type it, just type in the fraction, 77 over 400. Now for question number 27, because I have probability of B, let me use the red formula. Probability of B is 3 over 10. Probability of A not B, I don't know what it is. I'm going to call it X. Equals probability of A and B is 9 over 80. Now to simplify, I'm going to multiply it. To get the X by itself, I'm going to multiply both sides by 10 over 3. The fraction, the reciprocal of the fraction where X is. And the reason why, I want these 10s and these 3s to cancel out. So I have X by itself. Now 9 over 80 times 10 over 3, simplify first. 10 and 80, let me divide each by 10, so that's 1 and 8. 9 and 3, let me divide each by 3, that's 3 and 1. Now when you multiply across, Straight across on the top, I have 3 over 8. Make sure for the answer, you just type in the fraction, 3 backslash 8. So 3 over 8. Looking at question number 28, I have probability of B. So I'm going to be using the red formula. For the red formula, I have probability of B is 1 over 4 times probability of A not B, it's X. So I don't know what it is. Probability of A and B is 3 over 20. So I'm going to multiply both sides by 4 over 1. That way I get the X by itself. Now here, let me simplify the 4 and the 20. This 1 and 5. I divided each by 4. Now when I multiply straight on the top, I have 3 over 5. So X is equal to 3 over 5. Simple. Now for questions 29 through 32. Determine if events A and B are mutually exclusive. For me to know they are mutually exclusive, I'm going to have that probability of A plus probability of B is equal to probability of A or B. If that is true, I get mutually exclusive. If it is not true, I get not mutually exclusive. So keep in mind, in this case, I don't have a times. In this case, I have a plus. I'll come back in a minute to talk about the difference. Why do I have to go plus and not times? I'll come to that in a minute. But right now, I just have probability of A plus probability of B equals probability of A or B. So I have that 7 over 10 plus 1 over 5 equals 9 over 10. I want to have common denominator. When I'm having my fractions to have the same number at the bottom, I'm going to multiply my second fraction by 2. I'm going to multiply top and bottom by 2. So I have 7 over 10 plus 2 over 10 equals 9 over 10. I want to have common denominators. So I just look at the top. 7 plus 2 equal to 9. Because it is true, I have mutually exclusive. Now let's take a look at question number 30. Probability of A is 3 over 10 plus probability of B is 2 over 5. And probability of A or B is 29 over 50. All right, so to have common denominators, my first fraction, I'm going to multiply top and bottom by 5. My second fraction, I'm going to multiply everything by 10. I want the denominators to be 50, so I have that 15 over 50 plus 20 over 50 is equal to 29 over 50. Is that true? All right, is 15 plus 20 equal to 29? I know this is not true. Therefore, I'm going to say it not mutually exclusive. Take a look at question 31. I'm asking is 7 over 20 plus 1 over 5, is it equal to 11 over 20? I want to make my denominators 20. I want to have a common denominator, so I'm going to write 7 over 20 for the first fraction plus my second fraction. I'm going to multiply everything by 4. So I have 4 over 20 equals 11 over 20. Have the same denominator. So is 7 plus 4 equal to 11? Yeah, this case it is true. Therefore, mutually exclusive. Lastly, let's take a look at number 32. I have 3 over 5 plus 1 over 4 Is it equal to 7 over 10? I'm going to make my denominators 20 because I see my denominators, I can make them all 20. So the first fraction, let me multiply top and bottom by 2. By 4. My first fraction, let me multiply everything by 4 on the first fraction. So I have 12 over 20. The second fraction, let me multiply top and bottom by 5. So I have 5 over 20. The last fraction, let me multiply everything by 2. It gives me 14 over 20. I just wanted common denominators. So now I'm asking, is 12 plus 5? I'm just looking at the top. Is 12 plus 5 equal to 14? It is not true. Therefore, not mutually exclusive. I said I was going to come back into why sometimes it's times we multiplied and why sometimes we add. Now the difference is we multiplied when we're using the word and. Notice how 25 through 28, and as a matter of fact, on my previous examples at the beginning of this presentation, question 17 through 24, they all use the word and, so I was using multiplication. Now 29 through 32, they use the word or. That's when I add.